Hello guys and welcome back. So today will be our next day for the JEE Advanced 100-day question series. So guys, this question is taken from Vishal Tiwari Sir's notes, and I could have included it in the normal Vishal Tiwari Sir series, but I thought about including this here because this question is good, okay? And like a little bit of discrepancy also is there regarding this question. Like, I don't know whether this is correct or not, but I feel that this 5 here will actually be 6. Okay. I feel this will be 6. And like, as you see my solving of the problem, at last you will realize why I am telling this. Okay. Like, I will give you conclusive evidence to prove why I am telling this. Okay. Because after all, I am judging a question from Vishal Tiwari sir's notes. So if I am doing that, so we need some conclusive evidence, right? Okay, so guys, this question, like, it looks a bit odd that which of the following options is or are roots of the polynomial. You have an algebraic polynomial and the roots are trigonometric. So that is actually like the twist in the question. The question is really good. Okay, you might be wondering how we will do this, and I will give you a small blooper. You will be shocked. We will do this using complex. Okay, like not very purely using complex. So guys, if you want, you can try this question out once yourself, because I have already said that this will be using complex. So try to use your brains. I will wait for a few seconds and then start off solving this. Okay guys, I guess now it's time for us to solve this. So first thing is this p of x thing is given and we have to calculate p of sine theta. Okay. Okay, so guys, for the time being, I am working with this 5 thing as the 6 only that I marked in the beginning of the question. And at the end, I will tell you what would have happened if it was 5 and why do I feel that 5 staying would make it incomplete or incorrect. Okay, so let's start off. P of x is given to be equals to sigma r equals to 0 to 6 minus 1 powered r 13c2r plus 1 minus x square power 6 minus r, and this is x power 2r. Okay. And guys, like one more thing, I couldn't find out doesn't mean you also can't. Like if you can, like you have seen the question, right? So if you can solve this with r equals to 5, I like without my correction, maybe my correction would become a whole lot different sum with the same answer maybe in between these options. So if you have any alternative solution, or if you have anything else that like you have conclusive proof to say that this thing is actually correct and maybe I have done wrong, I could be wrong. Okay, so for that you can write out to me in the comment section, or you can directly message me on Telegram, okay, which is given on my description. I will possibly post that because this question is a really good question. I couldn't find anything else than putting 6 as the correction, but if you can find, then very good, and do message me. Okay. Anyways, so this is our expansion given, and now first thing that we would be doing is we would actually, like, because this is given in sine cos components, I mean the sine cos roots are given in trigonometric form, so we will try to express this complete polynomial as a function of sine theta. So basically what I am doing is I am putting x as equals to sine theta. Okay. So if we actually put here x as equal to sine theta, this will become sigma r equals to 0 to 6 minus 1 power r 13c to r plus 1, and this thing would actually become 1 minus sine square theta. Okay, so cos power 12 minus 2r theta and sine power 2r theta. Okay. Now guys, we will try to find out the value of this, and for that actually I developed a very cool method from Demoivre's theorem. Okay, I hope you know what Demoivre's theorem is from complex numbers. So we will try to find this out. Okay. Okay, so guys, what I'm doing is I am applying your Demoivre's theorem, cos theta plus I sin theta power n. Now we can actually make two forms of this. One form that we very commonly know, all of us know, is cos n theta plus I sin n theta. This is what everybody of us knows. Okay. But because it's an a plus b power n type, so we can also write it in form of a binomial expansion, right? General binomial term. So sigma k equals to 0 to n c k cos power n minus k theta, and I guess this will be I sine theta whole power k. Okay. So if we evaluate this a little bit, this will come out to be sigma k equals to 0 to n c k. This will be cosine power n minus k times theta. This will be I power k, or maybe I could have kept I power k in the starting anyways. And this is your sine power k theta. Okay. So now this is your summation, and we need to like find out our sine theta. Okay, now listen to me carefully. Thing is that this polynomial of ours is a function of sine theta. So what I guessed was, because in this particular sum you can see the imaginary part is actually sine theta, right? If I take this complex number to be some, say, z is equal to cosine theta plus I sine theta. So if this is the imaginary part of the complex number containing sine theta, I guess if we find out the imaginary part of this also, maybe we can equate both the parts. Okay, and how? Because cosine theta plus I sine theta power n is equal to this thing, and this thing is also equal to this thing. So we can actually equate this with like this part with the imaginary part of this expansion. Okay, I hope you have understood. So if we try to do that, like imaginary part for the normal, that complex number from Demoivre's theorem, it would be sine n theta. And from here, if we want to pull out the imaginary part, then just look carefully what I am doing. Like observe the sigma I am writing here. Okay, this will actually be sigma r greater than equal to 0, comma, like look at this carefully. This will be 2r plus 1 less than n. Okay, this basically means that the summation or the sigma here will operate on these two basic conditions. Now why 2r plus 1 less than n, you would ask? So we all know that our I power 4k is always equal to 1, and I square is minus 1. So like what will happen is only the odd terms will contain the imaginary parts, which is I guess very clear from this. Only odd terms will contain imaginary parts, so we would include only odd terms. Okay. So this thing would actually become, and one more thing, like odd terms. So if I take out, say, I power, I can take an example. Say if I take I power 9, then this would actually become I power, oh, okay, wait, I square power 2 into I. So, okay, no, I power 4, okay, wait. It's not I power, I square whole power 4 into I. So this would actually become I square minus 1 times 4. So I. Okay, so you can understand it's the odd power. So we can write this as your NC, and I am in place of k writing 2r plus 1 now. After this, you would have I power of 2r plus 1, and after this, you would have cosine power n minus of 2r plus 1 theta. Okay, and no space here, kind of. So I am writing this multiplied sine below. This is the same expression. Okay, so this will be sine power 2r plus 1 theta. Okay, so this is the expression, and now if we want to write this in terms of the, like, this was not the limit sigma term, this was a condition sigma. So if we want to write a limit sigma now, this will be sigma r equals to 0, and for this actually 2r plus 1 is less than n condition. So if we evaluate r from here, it will be n minus 1 by 2. Now r is actually less than n minus 1 by 2 here. Okay, so in the, like, this upper limit we can't write directly n minus 1 by 2. So in place of that, this will not make a difference in the original expression. What I am doing is I am writing box of n minus 1 by 2. Like, understand, for example, say if your n minus 1 by 2 evaluates to be some 3.2, then r, I mean the box function would be 3 itself, and r is less than n minus 1 by 2, or r is less than 3.2, so that means r becomes 3. Okay, like, it's pretty standardized now. So guys, I hope, yeah, we can proceed. So this is the sigma, And now what I'm gonna do is, like, see this carefully. I will write this as minus 1 power r and nc2r plus 1. After this will be cosine n minus 2r plus 1 theta. Like, you understood, right? Why minus 1 power r is coming? Because of this. Okay. Odd power of I. Okay, and this will be your sine power 2r theta. Okay, wait. Sine power 2r plus 1. Okay. Okay, let's do one thing. I'm jumping off one step. Okay. See carefully. Basically, this is your expression that is coming. And after this, what I'm going to do is sine power 2r plus 1 theta here. So I am taking sine theta from this term and bringing it to the denominator on the left hand side. This becomes sine n theta by sine theta is equal to this thing. Okay, like, guys, I would love to give a little bit of intro about this very special expression that if you guys have learned calculus, maybe you would have seen a lot of integration sums on this. Like, don't neglect this at all. This is one of the most universal expressions that you will see in your higher mathematics. Okay, basically, because, like, I had just explored this thing during my JEE, and this particular expression sine n theta by sine theta, you just saw this. I can write it in a form of complex numbers. Okay, like I and all, though it's not in a very complex form right now, but a while ago it was. Okay, but there are a lot of ways to prove, like, write this. You can even write it, maybe I will discuss that in some other video if I get a chance. You can also write sine n theta by sine theta as a product of sines also. Okay, you can consider this as a polynomial function. Like, how should I say, like this is a polynomial function that is a product of some roots, and those roots actually come out in sine. Okay, that is also a really long derivation. Like, this is a very universal expression. This has a lot of applications in integrals and higher mathematics also. Very genuine indeed. Okay, so that's why I had to speak a few words in honor of this. Anyways, so this is our expression that has come out. And now, guys, if you actually, like, put n as equal to 13 here, sine 13 theta by sine theta. Okay, you will actually, like, I will write this down, then you will understand. This will be sigma r equals to 0 and 13 minus 1 by 2. Now you will ask me that why have I put a correct value? This box function came out to be a correct value, blah blah. So, like, that is allowed, but here our constraint said something else, so I was bound to put a box. Okay, like, we are putting specific values here, but we don't know what is waiting for us inside the expression. Maybe the question would have been different and you would have got this as a decimal number, then what you would have done. Okay, so precaution is always necessary. So this becomes minus 1 power r and 6 c 2r plus 1. Okay, wait, not 6, this is 13. 13 c 2r plus 1 cosine power of 12 minus 2r theta sine power 2r theta. Okay, cool. So this thing has come out to be, and, like, you can see the expression that we wrote a while ago, that p of sine theta, that and this expression are exactly same. So we have actually come. This is our expression. Okay, and now actually I will explain why I felt that in place of 5 there in the question, you should have 6. Okay, I will explain that. Okay, guys, so consider that we have to find out, not for 6, not for my correction, but for what was given in the original question, for our, like, upper limit 5. Okay, so if we want to find upper limit 5, we actually have to shorten this sigma. So for that, this will be sigma r equals to 0 to 5 minus 1 power r 13c2r plus 1. This will be cosine 12 minus 2r theta sine power 2r theta, and you would have next one small term which is for for the r equals to sixth one that we eliminated from the sigma. So that would actually, if you evaluate that, it would actually come out to be sine power 12 theta. Okay, so actually the, like, According to the original question, the polynomial function comes out to be something like this. Not function, I would say equation. Plus sine power 12 theta. So this is your equation that is coming. Now guys, like if you have even little bit of brains in your mind, you can easily tell that theta here it will be n pi by 13. Okay, like if we want to make LHS 0, we are solving an equation for the roots, and if we want to make LHS 0, theta will be n pi by 13. But tell me one thing, how is n pi by 13 making the RHS 0? Like how? And we can't put theta equals to n pi, because if we do that, this part becomes undefined. Okay, this absolutely becomes undefined. And if that happens, then this equation has, it means that this equation has absolutely, like, it is not correct. If you are having an undefined term in an equation, that means that equation is not correct. So that was actually my place of concern. Like, because of the sine power 12 theta, everything is going off track. Okay, so I hope you can understand. So guys, in place of that, actually, if we had sine 13 theta by sine theta is equals to p of sine theta. Like, see, there are two methods. Either you equate both LHS or RHS, or what you do is you put this also equal to 0 and this also equal to 0. Same thing, right? So if you put this thing equal to 0, then theta is coming to be n pi. You put this thing equal to 0, theta will come to be n pi by 13, but both sides don't match. Okay. And kind of like one more thing, we actually like can't say that p of sine theta will be obviously 0 if theta is equal to n pi. You have never put p of 0 and checked whether it will be exactly equal to 0 or not. Okay, we haven't checked that. And moreover, it's not even satisfying this. So guys, I guess this will be your correct equation for not 5 but for 6. Okay. So guys, if in this place, like, see, one thing is that p of sine theta actually should not be judged, because p of sine theta was the original polynomial function, and we are not at all knowledgeable about the fact that p of 0 will be 0 or not. Okay, our work was to find out the roots. So on that basis, or whichever basis you see, I don't feel this thing is correct. Okay, this is my explanation. Still, if you have any other counter examples to this, or if you have developed any better method to solve this, then you can maybe comment down or message me. Okay, so going with this, guys, I hope sine 13 theta by sine theta, this thing will be equals to 0. So if this is equal to 0, I hope sine theta will not be a problem, and so theta will be equals to n pi by 13. So if theta is actually n pi by 13, I would make you recall that we had taken x as sine theta. Okay. Okay. So guys, up till this, and after this, like, we can easily, because x was put as equal to sine theta. So I guess we can equate x square as equals to sine square theta, or sine square n pi by 13. Now, there is a bit of discrepancy here, and discrepancy is in the fact that you will see the options. Maybe option C is actually matching with this thing, that is sine 4 pi by 13, which is obviously very matching, but in the answer key the option that was given to be correct was sine square 7 pi by 13. Okay, so now that actually could be correct and could not be correct with reference to my method, because if we take x square, then sine square n pi by 13 is actually correct. It can be, but in that particular case this would have been a function of x square then. Okay, although I think that if you observe carefully, every term in that binomial expansion, if you see that, like, binomial expansion which was given to us in the starting, there was this thing 1 minus x square power 6 minus r into x power 2r. Okay, So every term will actually contain x power 4, x square, x power 6, x power 8, something of that sort. Okay. So actually, if we somewhat say that this is a function of x square, then it's like not very wrong. Okay, although question officially mentions it as a function of x as y equals to p of x. So if we consider that, that actually regards option C as correct. But if we try to refer, like I saw the answer key, there it was given as sine square 7 pi by 13. Okay. So if we have to refer that, maybe you can use this logic that because x power like x power 2r multiples of 2 in the powers are present everywhere. So in that particular regard, you can actually say that sine square 7 pi by 13, or rather any sine square n pi by 13, can be also a root. Okay, that might be an explanation. So two cases and two explanations. Answer will be either A or C. Very doubtful actually. Okay, because I made a video on this question because it was a bit of interesting, this complex part, so I had to make, but the answer part is still a bit doubtful. Okay, anyways, I could be wrong, so if you guys have any other methods, then do message me. Okay, so guys, I hope till this will be the end for today's video and this question. So I hope you like the solving and the method. And that's it for today, guys. If you have liked my channel and this video, do like, share, and subscribe. If you have any solutions to this question, obviously do write down in the comment section, because I could be wrong. Okay, I'm telling you, I could be wrong, obviously, because it's a human solving this, not an AI. So even AI does mistakes. So maybe I will also do. So if you have any like further solutions to this, any better solutions, any concrete proof that I have done something wrong, A is correct only, C will not be correct, something of that sort, then do message me. Okay. But like it has to be some conclusive proof written in hand paper. Like don't go to Wolfram Alpha or any apps and then tell me that this is correct or not. Okay, I want a handwritten proof. So I hope that's it for today, guys. I hope you like this video. So let's end this video here, and thanks for watching.